So our goal for this week's review is to be able to graph using slope-intercept form, and that is going to help us with our lesson this week, which is to solve a system of equations by graphing. And so if we remember, slope-intercept form is y equals mx plus b. And in that particular form, we know that the m, the variable there, represents the slope, and that the number there, the b value, 0b, represents the y-intercept, which is the point at which the graph crosses over the y-axis. Remember that our x and y represent any and all ordered pairs that fall on the line. And so the first thing we're going to need to do is to take our given equation here, x plus y is equal to 3. And you can either do this on, if you have printed out some graph paper of your own, or if you go in the back of your algebra notebook, there are some just plain graphs that I put in there for us to practice on. Find a plain or a blank graph and work on those. So we're going to take it, we want to solve for y, so we want y left on that left side of the equation by itself. So that means we need to bring x over, and if that x is positive when it comes over, it's going to be negative. And then we're going to drop down that 3. And so what we have here is our slope-intercept form. Our y-intercept is at the point 0, 3. That's where we start at. So I'm going to go to 0, 3 and place a point. And then our slope is negative 1. And remember, we can also think of it as that as negative 1 over 1. So I'm going to go down 1 over 1 and continue that process. And you can see that negative slope is creating a line that is decreasing. And then I'm going to be able to take and to draw a line through these points. It'll be very beneficial as we go to do our graphing this week with solving equation systems by graphing, to try to get this graph as precise as possible. So correct placement of ordered pairs is what we want to do, and then to try to place that line as accurate as possible. All right, so if we look at the next one, we just want to keep practicing these so that we know that we remember how to do these going into this week. If we look at this, x plus 2y is equal to 4. We first need to get this into slope-intercept form. I'm going to leave the 2y where it is. It's a positive 2y, so I don't have to drop a sign down. I'm going to take that x and move it over. And when it goes to the other side, it becomes a negative, and then drop down the plus 4. And since this is 2 times y, I'm going to use my inverse operation. I'm going to have to divide everything by 2. And this will give me y equals negative 1/2 x plus 2. And so that tells me that my y-intercept, my starting value on the y-axis, is at 0, 2. So I'm going to place that point right there. And then my slope is negative 1/2. And so I'm going to move down 1 and to the right 2. And remember, I could always reverse that and go up 1 and to the left 2. And that'll give me the points here that are over in quadrant. And then I'm going to take and draw my line. Now you would be using a ruler or a straight edge to draw your line. I'm going to try to get mine as accurate as possible with the graphing tool to go through the points. Remember, we're going to try to extend it all the way through the coordinate plane. if we look at another one here, we have x minus y is equal to 1. And so this time we're still trying to get this into slope-intercept form. I need to be careful with this. A lot of times students will drop down the y, but look what's in front of the y. It's a negative sign, so I've got to drop down a negative 1y. I'm going to bring the x over to the other side. That's going to make that a negative x. I'm going to drop down the 1. It's going to make it a plus 1. Now, if I made the mistake of not dropping down this negative sign, I would think that negative x plus 1 is my answer. But I have this negative 1 here, so I have to take and divide everything by negative 1, which then makes my slope a positive 1x and my y-intercept a negative 1. Changes the graph greatly. And so our y-intercept for this particular problem is at the point 0, negative 1. And our slope is positive 1, which we can write as 1 over 1, up 1, right 1. Or we can reverse it, go down 1 and left 1. And then we could put our line in. All right, we have one last one we're going to practice, which is 3x minus 5y equals negative 30. So I'm going to start by dropping down the y value and looking right there to notice that it's a negative 5y. So I'm going to drop that down. I'm then going to take this 3x and move it from the left side over to the right side. It's going to become a negative 3x. The 30 is staying on the same side of the equal sign, so it's going to drop down and become negative 30. So now I have the y isolated, but it has a coefficient of negative 5, so I'm going to have to use inverse operations and divide all terms by negative 5. This will give me y equals, remember I want to keep that as a fraction, 3/5. I don't want to turn that into a decimal because I want to be able to see my rise over run. And then negative 30 divided by negative 5 is positive 6. So this tells me my y-intercept is at the point 0, 6. So let me plot that right there. And that my slope is 3/5, which is up 3 and to the right 5. Or I can reverse that, go down 3 and to the left 5 to get the other points. And then I can draw my line. And so remember that we'll be using this graphing with slope-intercept as we do our lesson this week. The other type of graphing that we want to remember is that, is that we will also have we will also have vertical and horizontal lines. So we want to remember that if we have a graph that is an equation, that is x equals 5, that if we look at our coordinate plane, that would be a vertical line where x is equal to 5. And then we know that if we have y equals 5 on our coordinate plane, that we're going to go to the y value of 5 and draw a horizontal line through there.